Hello students, welcome to Akshara 8 Foundation. So today we are going to discuss Newton's third law of motion. In the last class we have discussed about the Newton's second law and we have done the numericals on that Newton's second law and linear momentum also we have discussed there. So now Newton's third law. So the statement of Newton's third law will see there, for every action there is an equivalent and opposite reaction in the universe is known as the Newton's third law of motion there. So for example, and this action and reaction are both will be equal in magnitude and the opposite in direction there. So action and reaction will be equal in magnitude and opposite in direction. So if you take the example, ball and the wall, two objects there. So if the ball is thrown onto the wall, then ball will apply the force on the wall. That is called action. That is action. FAB will be the action there. So in the reaction there, wall will apply the force on the ball. So that is the reaction force. So due to that force, it will be comes back into the same side there. So that will be reaction will be acted by the wall on the ball in opposite direction. In opposite direction, both action and reaction will be equal, but they are in the opposite direction there. So this is Newton's third law of motion, and we'll see there there are many examples are there then. So for this Newton's third law of motion, suppose if a boat is moving, okay, rowing of boat is an example of this Newton's third law. So when the boatsman rowing the boat there, so he will be apply the force. He will be throws the water backwards, then the ship, then the boat will be moved forward there. Okay, the swimmer also. In the case of swimmer also, the swimmer will apply the force, okay, by his hands. So he will apply the force backwards, and in the reaction, the body will be moved forward in the water there. So swimmer, swimming of a person in the water. That is example of this Newton's third law of motion. Not only that, recoiling of gun. So when the gun has fired, then the bullets will be come out from the gun, and the gun will be moved backward direction there. Okay, that is called the recoiling velocity of the gun there. So when the gun has fired, then the bullet will be come out from the nozzle of the gun, and in the reaction, the gun will be gives the backward jerk. So that is called the Newton's third law. Newton's third law of motion. Action and reaction will be takes place there. So not only that, even the propulsion of rocket. So the rocket will be sent into the space by using this Newton's third law of motion. So action is the gases ejected from the nozzle of the rocket, with they will be apply the upthrust. So in the reaction, the rocket will be go into the space there. So here in this all the examples we have observed that this action and reaction will be act on two different bodies, not on the same body. Action and reaction will be act on two different bodies, not on the same bodies, and okay, and they will be equal in magnitude. The action and reaction will be equal in magnitude and opposite in direction there. Okay, so write down. So we'll see the example of recoiling of gun. Okay, suppose one more example we'll see there. So recoil velocity of the gun there. Recoil velocity of gun. Recoil velocity of gun there. So see here total momentum before the gun fires there. So let us consider this will be the gun. So whenever the gun has fired there, bullets will be there in the gun. No? So whenever the gun has fired there, so before the gun has fired, the total momentum of the gun. So this is the mass of the gun and the mass of the bullet. So whenever it has fired there, initially, so here mass, the gun will be at rest only. So U1 will be at rest. Even U2 also it is at rest there. Bullet is also at rest there. So now the total momentum before the gun fires there. So initial momentum will become 0 there. Initial momentum will become 0. So when now it has fired, after firing, the final momentum will be there then. Final momentum will be there. So that final momentum and this after gun fires, the bullet will be moved with certain speed here v, and the gun will be gives the backward there. That is the recoil velocity. Capital V will write there. Capital V. Okay. So now the total momentum it will become there. So small m into small v plus capital M into capital V. Capital M into capital V. According to the law of conservation of energy, the law of conservation of linear momentum. Sorry, law of conservation of linear momentum. The total momentum, so before and after action is equals to so that is initial momentum is equals to final momentum, or the change in total momentum will be 0 of an isolated object there, where there is no external force acting there. So gun has fired means there is an internal force only present there. Okay. So no external force. So F external will be 0. If F external will be 0, then this law of conservation of linear momentum will be exist there. It will be coming into the picture. So now the total here momentum, initial momentum, it is 0. Initial momentum will be 0 before the gun fires, and after the gun fires here the total momentum mv plus capital M into capital V. Okay. So from this the recoil velocity of the gun, if you bring here this one capital M into V this side, and it will become minus M into V will be there. So this is a capital V right on there. So capital V it is a recoiling velocity. So minus small m into small v, small m into small v divided by capital M we can add there. So this is a recoil velocity of the gun. So that is the recoil velocity of the gun. So this is, so this, the recoil velocity of the gun due to the Newton's third law of motion. Okay. Even though like the same manner the propulsion of rocket also will be takes place there. The ejection of gases coming out from the nozzle of the rocket, so that will be provides the rocket upthrust they will provide there, so that the rocket will be move into the space there. So action is provided by the ejecting gases of the rocket, and in the reaction it will be moved into the space there. Okay. So we can see here, suppose if an object is placed, on the body, object is placed on the floor, suppose if you consider there, object is placed on the floor. Okay. So the weight of the body will be act here downward direction, there is a mg, and opposite to this the normal reaction will be takes place here. So here the weight of the body placed on the surface, the weight will be the action acting on the surface on which it has placed there. In the reaction, so the surface will be apply the force on the body, that is in opposite direction. It is perpendicular to the body. That force will be act perpendicular to the body in opposite direction to the weight of the body there. Okay. So when these two are equal, the body will be at the equilibrium position there. So N is equals to mg, we can write here N is equal to mg. This N is said to be the normal reaction. N is said to be the normal reaction force. So N will be the normal reaction force, and mg will be the weight there. Normal reaction is nothing but the imaginary force or reaction force acting by the surface on the body whenever the body is placed on the surface, and it will be act perpendicular to the body there, perpendicular to the body in upward direction it will be act there. That is called the normal reaction force. And this also it is example for the action and reaction force, we can say that. Okay. So this is about the Newton's third law, and we'll see their concept based questions, and then exercise problems we'll see there. So one by one we'll see there now. Here concept based questions, practice sheet it is given, that will be seen there now. Practice sheet. Practice sheet. So concept based questions. Concept based questions. Okay. So first question is given: the force exerted by the first body on the second body is called. The force exerted by the first body on the second body is called the action force. So first one we can write here action, and second one is here according to the Newton's third law, to every action there is an equivalent and opposite reaction. So from the statement there is given there. So for every action there is equivalent and opposite reaction is there. So answer you write here equal and opposite. Equal and opposite. Equal and opposite. And third one, the action and reaction forces acts on two different bodies. Already said no. It will act on two different bodies. Different bodies. Acts on two different bodies. Action and reaction will act on two different bodies. And fourth one. So both action and reaction are forces. Action and reactions are forces. They are not the velocity, acceleration. Action and reaction are the forces. Action and reaction are the forces. Then now fifth one we will see there here. The force exerted by the second body on the first body is called there. So force exerted by. So this one, fourth one is force exerted by the second body on the first one. This one is a reaction here, and the fifth one is the both action and reactions are the forces. Action and reactions are the forces. Now here this is a force. Sixth one, a swimming is based by the principle of. Swimming is based by the principle of. Already we have discussed there. No, it is Newton's third law of motion there. So Newton's third law of motion. Newton's third law of motion. And seventh one we see here. A man is at rest beside the space station, so he can be move himself to the space station by the making use of Newton's dash law. Okay, so Newton's by which law the person can be moved? So means there is a man is rest beside the space station. He can move himself to the space station by making use of dash law. Okay. So there in the Newton first law and second law there is an external force should be applied there. In the Newton third law there is no external force. Due to the internal force he can. If a man is moving from station to the from the beside the station to the inside the station, he has to move by his internal energy, by his internal force. So it is a Newton's third law. So this seventh one also Newton's third law we can write there. So eighth one is given there. When we jump into the water, the boat will be moved. So if we jump into the water, the boat will be moved backward there. Okay, that is reaction. So we are jumping into the water is the action, and the boat is moving backward is the reaction there. So that is called the. So here it is backward direction. It will be moved backward direction. Backward direction. And ninth one. When we kick a stone, we get hurt is due to. When we kick a stone, due to. So reaction force. There is a more reaction will be there for the stone. For the ball, it is a less reaction will be there. So the reaction will be greater there. Due to that, it will be so act the reaction force. So this is about the concept based questions there, and we'll see now the conceptual questions there. Exercise problems. A runner covers more distance on the land than the swimmer in the water because of. Okay. So there also the sand will apply the lesser reaction there. So due to that means the water will be. So here it is given there water offers less reaction. Our feet sinks into the sand there. Water offers more reaction. Both 1 and 2 is given there. Okay, runner covers more distance in the land than the swimmer. So here The water applies the less reaction. First one we can add there. Water applies the less reaction. So water applies the less reaction so that you cannot move faster. Okay. Concept exercise problem. First one. Option 1 we can add there. Option 1. So exercise problem. First one. Option 1. Option 1 is the right answer. The next one you see there here. So it is difficult to walk. It is difficult to walk and sandy beach because. So it is difficult to walk because the reaction, the sandy beaches, the sand will be apply the less reaction on the food. Okay, food will apply the force. No action will be takes place, but reaction will be less reaction. So that is, it is difficult. That means here it is given there. Sand offers the less reaction. Our feet sinks into the sand there. So because the sand offers less reaction, so that it will be sinks into the water. So that here sinks into the sand we can add there. So fourth one option. Second one is the fourth one. Second one option. Second one. Fourth one. 1 and 2 we can add there. 1 and 2 is the right answer. And third one we'll see. Action reaction never be balanced because they are opposite direction there. So they will be equal in magnitude, but they are in opposite direction there. Okay. So here the options are given there. They are equal but not in opposite always. They are unequal in magnitudes. Okay, that is first one we can add there. They are equal but not opposite always. Okay. Though they are equal in magnitude, opposite in direction, they act on different bodies there. They act on different bodies. They are unequal in magnitudes there. So we can write here they are equal but opposite in direction always. Okay. So they act on the two different bodies. Yes. So we can write here third one. We can write. So third one is the right option. And next, if the action, fourth one is given here. If action on a body is gravitational in nature, the reaction force is. So action force on a body is gravitational in nature there. Action force is gravitational in nature. Reaction force is. It may be contact force, must be gravitational too, and may be gravitational or contact force, may be a force of any origin. There. So action force is action means it should be a contact force. Here ball, in the example we have seen, ball applied the force on the ball there. If a ball is thrown onto the wall, so ball will apply the force on the wall there. So that is action. Then if it is action, it should be a contact force there. Okay. So if it is a contact force, then the gravitation force is not a contact force. Okay. So if the action force is a gravitational in nature, then the reaction. So let us consider here ball is falling freely. So it is whenever the ball is falling freely, in that case, so due to the gravitational force, it is falling on the surface. Then in the reaction, it will be rebounds into the certain height into the air there. So in that case, we can consider there. So now here both we can add then. Maybe contact force must be gravitational too. Okay, maybe gravitational or contact force we can add there. So maybe gravitational or contact force we can add there. So action is the gravitational force. Okay, it is, if it is a gravitational force and it is a contact force also. Okay, so then here maybe option 3 we can add there. Fourth one is option 3. Option 3. So while walking, if someone steps on the banana peel, he loses its balance and falls because of. Okay. So there is a reaction force will become less. Okay, reaction force. If action is what there, we apply the force on the banana peel there. So banana peel will apply the less reaction so that we will be fall there. So here the options are given. Banana peel is in yellow color. Banana peel offers large reaction than the action. Banana peel offers less reaction. So here we can add there. And banana will offers less reaction. So here the fifth one we can write there option 3. Option 3 is the right answer. And sixth one is given here. Sixth one, the rising of the rocket can be best example, best explained by which law? So Newton's third law of motion. Already we have discussed now. So sixth one is Newton's third law of motion. There is option now. So which law it is saying there? Newton's third law of motion. 3, option 3. So this is also option 3 only. And seventh one, action after firing the recoil due to. So that is due to the reaction there. So conservation of energy, kinetic energy, backward force of gases produced, backward force of gases produced, potential energy, action after firing, recoil due to, okay, backward force of gases produced, okay, backward forces. So we can add here backward force. Second one, seventh one is option 2, we can add there. Option 2 is the right answer there. Okay. And now next one, eighth one, we'll see there here. A man is at rest in the middle of the pond on perfectly smooth ice. He can get himself by using the Newton's dash law. Okay. So there is a man has to be on the rest in the middle of the pond means the ice will be the smooth surface. Ice will be the smooth surface. Then he will be stand on the rest on the smooth surface. So he has to be continuously. He has to be apply the force. There is a force has to be applied there. So the by speeds he has to apply the force on the ice cube, ice. So then, so here there is an action. So while we are applying the foot on the ice, there is action will be takes place in the reaction. So it will be applied the reaction. The reaction will be takes place. So we can write here third law, Newton's third law. Eighth one is Newton's third law. We can write there. Okay. So ninth one, which are the following works on the principle of Newton's third law? So rowing a boat, a man walking on the floor, both 1 and 2. So neither 1 nor 2 it is given there. So both 1 and 2 we can add there. A man rowing the boat. Rowing of a boat is an example for Newton's third law, and even the man walking on the floor also. We will apply the force backward so that we will be move forward there. So next one, 10th one, a jet plane works on the principle of. So here 9th one we can add there. 9th one is option. 9th one is option 3. So 10th one, a jet plane works on the principle of Newton's third law of motion, Newton's second law of motion, Newton's first law of motion. Option C is given there, Newton's third law of motion. So this is a Newton third law of motion, option 3 there. So 11th one, rocket diverts the necessary thrust to move forward according to the Newtons. Rocket drivers necessary thrust. Rocket drives the necessary thrust to move forward according to the Newton's dash law. Newton's dash law. So according to the Newton's third law. So 11th one is according to the Newton's third law. So option 3. Newton's third law. The 12th one is given here. The action and reaction forces refers to the Newton's third law dash. Action and reaction refers to action and reaction forces refers to Newton's third law. Must be act on the same body, must be act on the different bodies, need not equal. So this is option 2. So 12th one is option 2. The forces will be act on two different bodies now. So this is option 2 is the right answer. Next one. 13th one. A gun recoil after the firing due to. So that is due to the Newton's third law. So it is Newton's third law. That is also option 3. Newton's third law of motion. So 14th one, a man is walking from east to west on the rough surface. The force on the man is directive. So he is moving east to west. East to moving means So the reaction will back to west to east. He is moving. He is moving towards this one. East to west, east to west. Means he will apply the force towards east. And then he is moving there. In the reaction, so the person is applying the force towards east and east to west. In the reaction, east to west. Reaction will be east to west. So here the option from west to east to west is given there. So option 2, 14th one we can add there, option 2 there. 14th one is option 2. And 15th one, in jet engines and rockets, the hot gases comes out of nozzle with great force is called there. That is a action. There the action there. So it is option 2. 15th one we can add there, option 2. Option 2 is the right answer. Now 16th one we'll see. So car accelerate on a horizontal road due to the force exerted by the. So car accelerated on the horizontal road due to the force exerted by. So force exerted by the tires on the road. Force exerted by the tires on the road. The engine of the year, the options are given there, road on the car, force exerted by the road on the car. So the engine of the car on the earth. Car applied the force on the earth there. Okay. Driver of the car. The acceleration on the horizontal road due to the force exerted by. Force exerted by. So action is the tires will apply the force on the surface road and the road will apply the force. In the reaction road will apply the force on the tires there so that it will be move there. So what can we add there now? The car on the earth. So option 3 we can add. The 16th one is option 3. So now 17th one. When a horse pulls cart, the force which helps the horse to move forward. Okay. So when a horse pulls a cart, the force which helps the horse to move forward is force exerted by. Okay, it is same like that previous problem only, previous question. So if the horse is pulling the cart means it will be apply the force on the earth, the legs, the cart on the ground. Options are given there. Ground on the cart, horse on the ground. So it will apply the force on the ground. Horse will apply the force on the ground there. So it is 17th one is option 3 we can add there. Option 3. So next one is their numerical type answers are there. A body exerts a force 10 Newton on the ground, then the reaction of the ground is. So reaction of the ground we can add there. So 18th one we can add there minus 10. So the reaction will be in opposite direction. So magnitude is same but that is in opposite direction. Minus indicates the reaction. That is, it is in the opposite direction. Action is 5 newtons. The reaction is 5 newtons. So reaction is what? 19th one is also minus 5. Action is 5 newtons means reaction will be minus 5 newtons. So weighing machine records 35 kg. When a body stands on it, then the reaction of the machine is. Okay, so reaction of weighing machine records 35 kg of a boy stands on it there. Then reaction will be what there? Normal reaction. So the reaction is nothing but then reaction of the machine is same will get there 35 only. Okay, so this is but it is in opposite direction minus 35 kg. It will records minus 35 kg. Then that is minus indicates here in opposite direction there. Minus indicates opposite direction. Okay. So that is about this Newton's third law of motion. In the next class, we will start the next chapter. Okay. Thank you, children. Have a nice day.